to you
Mm-hmm.
of what we've done.
Yeah.
So let's see. Trying to think. I think today let's cover all of them, not just odd and even.
Sure.
Now, tell me how much you've done on circles in geometry.
We actually briefly covered it like a day or two, like out of the whole semester. I mean, we didn't really do much on it.
Well, there's not really much to
Yeah.
know on circles. What's the formula for area?
Area is equal to
Roll off.
it's pi times radius squared.
It should roll off your tongue like a fine wine. Pi r squared.
Pi r squared. Okay.
Okay? And
Yeah.
you know how I remember that?
How?
Because pi aren't square, they're circular.
Oh yeah.
So
Okay.
it's funny. I mean, pi r squared. The way to remember stuff is to make up a ridiculous version of it and
Yeah.
an image of it. And so if you imagine that pi r square, I guess they're square in Chicago, pizza pie.
I guess so. Yeah.
In general, pi are round, so pi r squared has a certain ring to it. And then
Interesting. Yeah.
circumference equals,
Circumference is equal to the
what is
pi times diameter, is it?
formula? Don't remember it that way.
Okay.
Remember it this way.
Oh yeah, 2 pi.
2 pi r.
Okay.
And it's, remember it as r. You know, I mean, r is always going to be radius. These are the only two formulas that you need to talk about circles, pretty much. And
Okay.
notice that radius tells you everything. If you know the radius of a circle, you know its area. If you know the radius of a circle, you know its circumference. That's why
Okay.
I don't really like using this. It's correct. Pi times diameter is the circumference, but diameter isn't the useful number that radius is.
Yeah.
So here's your two general formulas, and even if you haven't done much circles in class yet, you will shortly. So this will not be wasted.
Awesome.
You'll get, in fact, I'm kind of amazed that you've gone this far in geometry and they haven't covered circles yet.
Yeah, seriously.
So, okay, let's look at the first one. If the area of a circle is 64 pi, then the circumference of the circle is what?
So the area of the circle. So you just do pi times 64 times.
Hold on. Let's do this step by step. And let's know what we're going to do. We're going to use the fact that they gave us the area. So I'm going to fill that number in with 64 pi.
Okay.
Okay, and instead of writing area, I'm writing 64 pi because they told us that the area was 64 pi.
Okay.
Okay. Now I have to solve that equation, and like I said, you solve equations for one of these three variables, A, C, or R. In this case, we're going to be able to solve for R.
Yeah.
That's what we get as the next step. Now, once we solve for R, then we're going to be able to solve for C.
Okay.
Because we'll know R. I don't know what C is relative to area, but I definitely know what the circumference is relative to R.
Okay.
Let's go through those steps. Solve this equation starting at the bottom here.
Okay. So it's 64 times pi. So we would multiply 64 times 3.14.
No, never do that.
Never do that?
Never do that. Not unless the problem specifically asks you to.
Okay.
Pi is the most accurate and important number in the universe. Let's not be rounding it off.
Okay.
It may seem like a strange statement, but it isn't. From this point forward, all of your answers will be in pi. I'd be amazed if your teacher asks you to give a decimal approximation for it. I'd shoot him.
Yeah.
Shouldn't.
Yeah.
Maybe in Algebra 1 they do that, and maybe in the first semester geometry they do that, but they should not do it after that.
Yeah.
So how do I solve this equation? I'm trying to
Okay.
isolate r. What's happening with r squared at the moment?
It's being squared, so we'd find the square root of it.
Hold on. Not yet. At the
Not yet.
moment. In other words, it's not the pi and the r that are being squared. It's just the r.
Mhm.
This would be different if I did that.
Yeah. Okay.
Okay? So, before we can take the square root of both sides, if I take the square root of both sides now, I'm going to end up with the square root of pi times r. That's what I would end up with on the right side. That's not what I want.
No.
I want to try to isolate r as much as you can before going forward. Now, do remember that pi is just a number. It's no different than if I had a multiplier of 2 here or a multiplier of 4, what would your first step be?
Just divide it.
Okay, so let's do that.
Okay.
Divide both sides by pi.
Okay.
What's that turn the left side into?
That turns the left side into, 64. You just use 64 divided by 3.14.
No. Forget that pi is 3.14.
Okay, just totally forget it.
Well, here's what's happening here. This pi cancels with that pi.
Yeah.
So we lose the irrationality of it. And the answer
Okay.
is 64 equals r squared.
Okay, and then we would just find the square root of, find the square root of r squared.
So what's r equal to?
It's 8.
Okay.
R is equal to 8. Yeah.
Now, they want to know the circumference. And just like every geometry problem, it's a multi-step process.
Uh-huh.
They didn't give us r and say, what's the circumference? They gave us area, which allowed us to calculate r, and now we can calculate the circumference. So what is the circumference? Let's erase all of this. We know r is 8. What is the circumference?
So BC is equal to 2 times pi times 8.
16.
2 pi 8.
Combine.
Yeah, so 16.
In other words, always combine numbers when you can.
Yeah.
16.
Okay.
All right.
All right, cool.
Now, circles are actually pretty easy. The fact maybe they did cover them and they only spent 1 or 2 days on them because there's more advanced stuff on circles. But when you're talking about those two formulas and the radius, it's pretty straightforward.
Yeah, definitely.
Even a problem like this, which looks really complicated, but isn't.
Okay.
I have to figure out how to draw the circles, though. This is not going to be easy for me.
Yeah.
Not being an artist.
No problem.
The center is right there. So here, see if I had a compass, I could do this. I would just stick my needle right there, make that the measuring distance, and so forth and so on. All right. So they want to know, look at the last question first sometimes is helpful. What's the perimeter of this triangle?
Okay.
Okay. And what they give us are the radii of the circle. In other words, circle A has a radius of 2, circle B has a radius of 3, and circle C has a radius of 4.
Yeah.
So, what are the dimensions of this triangle? Let's label those radiuses. That's 2, and that goes from there to there. Remember something else about radiuses. all radiuses within the same circle are equal. So if this one's 2, all of these others are 2 also. I don't need those others. They're not helpful to have in the picture, but it's important to see that that measurement from there to there is 2.
Yeah.
This one's 3.
Mm-hmm.
And this one
No, 4.
is 4.
Mm-hmm.
And the way I drew it is a little confusing because the point that crosses is the perfect there. In other words, this one is 4 also, right?
Yeah.
It's 4 from here to here, but it's also 4 from there to there. And if it's 3 from here to here, then it's also 3 there to there.
Mm-hmm.
Tell me the perimeter of the triangle.
Okay. So the perimeter of the triangle would be... How would we do that? Just add them up and then...
Yep. In other words, what is the perimeter of a triangle?
Well, we know the area is based on side divided by 2.
What's the perimeter? What's the definition of it? Describe it to me. If I had a triangle that was 5, 6, 7, what would its perimeter be?
Its perimeter would be 18.
Okay.
Or divided by... What do you divide by 2 just now?
No. Perimeter is the sum of the outsides.
Okay.
If I have a square that is 4 by 4 by 4 by 4, that perimeter is 4 plus 4 plus 4 plus 4, or 16.
Yeah.
It's a bad example because the perimeter and the area are the same. But the perimeter is just the surrounding distance. It's the same as circumference.
Okay.
Perimeter and circumference mean the same thing. It's the measurement around the outside of the figure.
Okay.
On the edge.
Mm-hmm.
Okay.
So the perimeter of that would be 12.
What's that side?
7.
What's this side?
5.
And what's this side?
6.
18.
18, okay. Okay, I was kind of confused because the 4 was on the inside.
Well, I purposefully didn't write the last figure there. Hold on, let me erase.
Sure.
In other words, there was a 2 right here that I didn't put in there.
Oh, okay.
Okay, but I didn't do that. I left it out on purpose because it's not 4 from there to there. 4 is the radius of this big circle. It's 4 from the center to its edge.
Yeah.
No matter which direction I go, if I measure that, that's 4. If I measure that, that's 4. So it just so happens that from here to this point of tangency, where these two circles are touching one another, that's 4.
Yeah. Okay.
We know from that point of tangency to there is 3, so we can figure out the length of that side.
Okay.
That was 2. Let's go up here and do 3.
Okay.
Now,
all right.
Let's talk for a minute about circles and sectors. One thing you probably maybe have not covered is sectors with a lump on the side of their head. There's a circle.
Okay.
If I want to draw a right angle, what part of the circle is that?
That's 1/4 of the circle.
Okay. What part of the circumference? That's 1/4 of the area.
Mm-hmm.
What part of the circumference is that arc length?
Half of the circle.
Look again. You did that probably because of the relationship between linear and area, didn't you? Yeah.
Yeah. Mm-hmm.
Which doesn't apply here.
Okay.
Oddly enough, that's a very interesting observation. If I look at this, what does it look like that part of the circumference is? Does it look like half?
Yeah.
Oh, no, hold on.
Well.
I went all the way halfway to a semicircle.
Yeah, then it would be half.
Half. So it's half from this point all the way around to this point. So
yeah.
What is it from here to here?
1/4.
Yes.
Okay.
How many degrees is it to go all the way around the circle?
360.
Okay. And how many is this? This is 90. So we get that by dividing whatever the angle is by 360. And that's how we know it's 1/4. And we know it's 1/4 of the area, and it's 1/4 of the circumference.
Yeah.
Which is odd. Very odd. I never had realized that before. Because when you're generally dealing with comparing those, one is the square of the other. But in this case, well, okay, I see now what's going on. We're not really, when we talk about what the area of that quadrant is, we're not really comparing it with the circumference, with this arc length. Incidentally, that's what these are called, is arc lengths.
Okay.
If I go from here to here, there's a certain arc length. In other words, if that was a piece of string and you straightened it out, what would its length be? Well, you don't know.
Yeah.
I'm giving you enough information. I'm just trying to describe to you what arc length means.
Okay.
If I draw a circle with a piece of string, cut the string and straighten it out and lay it on the table, that's the circumference.
Yeah.
Okay? So.
Okay.
This concept is, this question, the concept is referring to how we talk about sectors. These are called sectors. Okay? This is called the arc length. This is called the sector, which is the piece of pie that we've cut out. Now, it isn't always going to be 90 or 180. Let's make it 30 degrees.
Okay.
In other words, this angle is 30 degrees. So what part of the area of the circle would this sector represent? Even if I don't know the radius. Notice I don't know the radius here.
Yeah.
But it doesn't matter. I'm still going to be able to figure out what the ratio is of the area of that sector to the area of the whole circle. How did we do it when it was 90 degrees?
When it was 90 degrees, we
did 90 divided by 360 to get 1/4.
Yeah.
What do we
so we would do 30 divided by 360, which would be 1/12.
That's what the area of that is. In other words, if somebody came to you and said, the area of this whole pie is, this whole piece of pie is 12 pi, that's the area, then you could say, well, the piece of pumpkin pie that somebody just took there that was a 30-degree slice has an area of 1/12 that, or just pi.
Okay.
So that's what they're referring to. And these questions, which are also quite a bit on the ACT test, where you have to figure out sector areas and arc lengths.
Oh, wow.
Just know, well, it's not hard. Arc length is part of the circumference. Notice
Okay.
if my arc length goes all the way around, I have one complete circumference. I know that that's 2 pi times the radius. Okay?
Okay. Yeah.
So this is not tough. It's actually pretty easy. The magic number in these kind of problems is 360. Because if I want to draw an angle completely around the whole thing, that has to be a 360-degree angle. Okay.
Okay, cool.
So let's do this problem.
Okay.
In the figure above, the ratio of the circumference of the entire circle to the length of arc ADC. Are you familiar with the arc length terminology?
Not really, no.
It's okay.
Yeah.
It's not going to hurt you to get a step up on this. I would guess this is probably the first thing you'll start out with, unless maybe it's algebra review. But this is going to be important stuff. So maybe the secret with you will be to get out ahead of it.
Yeah, definitely.
Okay, so what they're saying is the entire circumference relative to the ADC is 8 relative to 1.
Okay.
What is the value of x? What does x divided by 360 have to be?
Just 1?
No, here's our ratio. They're telling us what the ratio is.
So it is equal to 8 to 1?
Yeah, only the way I've written it needs to be 1 to 8.
Yeah.
Because I've written it, x is to 360, so the small angle relative to the big angle has to be in the same ratio as the small arc relative to the big arc.
Okay.
Okay, and it's not the small arc relative to the rest of it, it's the small arc relative to the entire circle.
Yeah.
So we know that ratio is 8 to 1. And I could have written this as ADC is to the circumference of the circle as 1 is to 8. Well, therefore, angle X is to 360 degrees as 1 is to 8.
Yeah. Okay.
Solve that.
So X would be equal to 45. You get 8x is equal to 360, and then divide by 8.
Yeah, let's go over something.
Okay.
Just because you can cross multiply doesn't mean you should. How many times have I said that?
Quite a bit.
Okay. This is a case. And the reason is that I'm trying to solve for x.
Yeah.
Why multiply it by 8 when the next thing I'm going to have to do is divide it by 8?
Yeah.
Okay.
True.
So it's a little silly to do this because the next step is that.
Yeah.
Okay, why not just multiply both sides by 360 and then you have x is your answer. It's 360 divided by 8. And that's what's equal to 45.
Okay.
Okay, so in general, and you're not the only one, everybody makes that mistake. So that's why I ask you how many times I've said it. I don't know how many times I've said it to you. I know I've said it 100 times though.
Yeah.
To all my students. Because everybody immediately, when they see a fraction equals a fraction, they want to cross multiply. Well, you only need to if your variable is in the denominator. Notice that if I had set it up this way, 360 is to x as 8 is to 1.
Then you would have to cross multiply.
I do have to, yeah, because I can't solve for x in one step.
No.
I have to get it into the numerator.
Mm-hmm.
So there's a certain advantage when you set up these ratios, just kind of keeping in the back of your mind, put your variable in the numerator if you can.
Okay.
Okay,
Mm-hmm.
and these ratios apply to all kinds of things, similar triangles and stuff like that. So
Mm-hmm.
if you're setting up a similar triangle and you have a choice of putting it one way or the other, like we did here,
Yeah.
put your variable in the numerator.
Okay. That makes sense.
Okay,
Okay.
let me draw this.
Sure.
There's one semicircle.
Mm-hmm.
There is another semicircle. And they're saying that AB
Mm-hmm.
is 4
Mm-hmm.
and AC is 2. So what is this dimension right here?
Uh,
Excuse me,
AC.
AC is 6. So that's got to be
Yeah.
2.
That's 2. Yeah.
Okay.
Okay.
What else are they saying? Let's see. What fraction of the larger semicircle does the shaded area represent?
Okay.
Okay, now let's think about this. What you
Mm-hmm.
always want to do is work backwards on these.
Okay. Yeah.
Before, in other words, this is slightly more complicated than the question would be if they say, what is the area of the shaded region? Let's
Mm-hmm.
find that first.
Okay.
Okay, before we can find the ratio of the area of the shaded region to the area of the larger semicircle, we need to find the area of the shaded region.
Okay.
Okay, what kind of problem is this?
Subtraction.
Okay, and conceptually, what's it going to be? The area of what minus the area of what equals
The area.
area
Yeah.
of the shaded region.
Mm-hmm.
So area of what?
The area of the, I guess, non-shaded region.
No, what's the area of the big thing? In other words, we're going to get this area by finding
Yeah.
the area of the big semicircle
Mm-hmm.
and subtracting out the area of the little semicircle. In other words,
Okay.
take the big minus the white, and we're left with the gray.
Okay.
Okay, so let's write it like that. We're going to take the area of the large semicircle. We're going
Mm-hmm.
to subtract out the area of the small semicircle, and we're going to get the area of the shaded region.
Okay.
Now we'll fill in everything.
Okay.
This is the way you want to do geometry. You always want to start with the general, and then you can, would they give us enough information to fill that in and that in, which will give us that, and then we'll
Mm-hmm.
be able to actually answer their question once we
Okay.
figure out its area.
Yeah.
The area of the large semicircle.
The area of the large semicircle is
Start with the general formula. What's the area of a semicircle?
area is equal to the square root of
No? Let's start with the area of a circle.
okay, yeah, so it's area is equal to pi r squared.
Okay. So the area of a semicircle would be that over 2.
Okay, so you just divide it by 2.
Yeah. In other words, a semicircle is half of a circle. Half of the circumference, half of the area. It's just half. Okay?
Okay.
Quarter circle is quarter of the circle.
Mm-hmm.
But semicircles you deal a lot with, just because they can make up interesting problems like this. So, they make you do one extra level of math.
Yeah.
What's R for the large circle?
For the large circle.
Semicircle. For the large semicircle.
R is 6,
No, that's the diameter.
so it'd be 3.
Okay. So what we have here is, I'm going to substitute 3 for r.
Okay.
So it's 9 pi over 2. That's
Okay.
this, the area of the large circle. Now, what's the area of the small semicircle?
The area of the small circle is 4.
What's the area of the small semicircle? And your answers almost always need the number pi in them.
Yeah, so 4 pi.
Okay, that's the area of the circle.
So it'd be 2 pi.
Yeah, let's not get confused here.
Okay.
This radius is 2.
Mm-hmm.
So the area of the full circle would be 4 pi.
Yeah.
But half of it is going to be 2 pi.
Okay.
So that is that.
Mm-hmm.
So now we know what the area of the shaded region is. What is 9 pi over 2 minus 2 pi?
It would be 7 pi over 2.
No, find a common denominator.
Oh, that's right. So just 2 would be a good
Okay, what does this become if I give it a denominator of 2?
just 1.
No.
Or just 2 without the pi, right?
No. Hold on.
Oh, okay.
Don't let pi confuse you. Pi is a number.
Yeah.
Okay? It's not a variable. It's a number. So we're going to apply everything we know about fractions. If I told you to do this, you'd be able to do it.
Yeah.
Okay? Well, this is no different.
Okay.
My common denominator is 2.
Mm-hmm.
So whatever this number is has to have a 2 down there. And now I have to figure out what to make its numerator such that the whole thing is still 2 pi. Well, what would the numerator be that would cause that to be the case?
Just 2. 2 pi.
2 pi over 2 is the same as that?
No, it's not. So we would have to do...
So you do that check.
Mm-hmm.
So what number has to go down here?
4.
Okay.
Okay.
That's the key.
Okay.
The moment you do it, make sure you look at this and notice that it has not been changed. That's the key. You can't change these things. You can just write them in a different way. And now, because we have a common denominator, we can actually do that subtraction. What is it?
So you would get 5 pi over 2.
Correct.
Cool.
Now, so that's the area of the shaded region is 5 pi over 2. But this question, geez, is this intermediate or basic? How did we get such hard questions? No, this is basic circles. Okay.
All right.
It's just that they've added multiple layers of questions. In other words, it would have been a perfectly good geometry problem had they just said, give us the area of the shaded region. Well, they've added one level of complexity to it. They want, what's the fraction of the larger semicircle does the shaded region represent? Well, conceptually, what does that mean? What's the fraction of the shaded region does the, what fraction of the larger semicircle does the shaded region represent? So what ratio are they talking about?
They're talking about the ratio we just found, right?
No, by that I mean we have 3 different things here. We have the area of this semicircle, we have the area of the big semicircle, and we have the area of the shaded region.
Yeah.
So they're looking for a ratio. In other words, let's Here's the area of the shaded region. Here's the area of the large semicircle. And that was 9 pi over 2. And our third thing that we calculated was the area of the small semicircle. And that was 2 pi.
Yeah.
Okay. So what are they asking? Which ratio are they asking for here? Read that last sentence. This is big for you to be able to put what they're saying here into a proper ratio and give it to me in terms of these things.
Okay, so it's asking for for what fraction of the larger semicircle does the shaded region represent?
So what's the ratio they're looking for?
So they're looking for the ratio 9 pi over 2.
No, don't give it
Area
a
of the
number.
shaded region.
Give it to me in terms of this stuff. Are they
Oh,
looking for the area of the small semicircle over the large semicircle?
yeah, they're looking for the area of the large semicircle.
No. What does that thing say? What is that half? What does it say from this comma to the end?
What fraction of the larger semicircle does the shaded region represent? So they're asking for the area of the shaded region.
No, they're asking for a ratio, a fraction.
Yeah.
If they were asking for the area of the shaded region, they would have said, what's the area of the shaded region? That's all they would have had to say. They're saying, what fraction of the larger semicircle does the shaded region represent? What they're asking for is the ratio of the shaded region to the larger semicircle.
Okay.
That's the ratio they want.
Okay.
Okay, well, what is that ratio?
Then that ratio would be...
Let's spell it out, and then we'll simplify it.
Okay, 5 pi over 2, and then 9 pi over 2.
Don't ever try to do these in one step. They're too hard for everybody.
Yeah, definitely.
Just write it like that, and now simplify it. How do I simplify that?
How could we could...
How do you divide by a fraction?
You multiply.
By
the reciprocal.
Okay. So how do I do this?
So you do 5 pi over 2 times 2 pi over 9.
Don't. Make sure you do the reciprocal. It's not 2 pi over 9. It's 2 over
2 over 9 pi, my bad.
Okay? That's the reciprocal. You have to reciprocate everything, both the numerator and the denominator. Which is nice because now the pi's cancel. And the 2's cancel. And our ratio is
5 nines.
So the ratio of the shaded region, they could have worded that many different ways. They kind of chose the most complicated way possible to word that last part of that sentence.
Yeah.
But a better way would have been to say, what is the ratio of the shaded region versus the large semicircle? You know, they could have stated it that straightforwardly.
Yeah.
But you're going to run into all kinds of word problems that state things in a weird manner that you have to figure out. You know, it's like whenever they say there's a number that's 8 less than another number, you don't put the 8 in front, even though they write it in front. It's always x minus 8. If I have a number that's 8 less than another number, this is the way I write it. The way I say it is I mention the 8 before I do the other number.
Yeah, so it'd be 8 minus 6.
And they always do this. You will not find a word problem that says you have a number that is 8 less another number.
Yeah.
It's always 8 less than another number.
Okay.
which means the order that you have to put it in. Well, same thing with ratios. They're going to give you these things defined in all kinds of ways.
Yeah.
All right, let's see. Somehow close that page out. I'm not sure I meant to. I guess that was all of it.
Okay.
Let's have a look. This might say intermediate, but I don't think it's any tougher than the ones we just did.
Okay.
Some of them might be, but these aren't.
All right. All right.
In fact, this is going to be a little geometry, which is good. That's what we want. Combine circles.
Yeah.
I mean, a little bit of triangles is what I meant. All right. So, we have the following picture. A line joining 2 points on the circumference of a circle is 1 inch from the center of the circle at its closest point. So here's the center of the circle. And it has a 2-inch radius.
Okay.
So they're saying that if I have a line that goes from that point of the circle to that point of the circle, it'll be 1 inch from the center of the circle.
Okay.
And in fact, what is the length of this line? Okay, that's a good question.
Yeah.
How am I gonna solve for the length of that line? Let me make this 2 and make that 1.
Okay.
Okay. In other words, this segment is 1 from here to here, and it's 1 from here to here. And we basically have to solve for that. And then once we solve for that, it's going to be the same as this one over here. So we'll multiply it by 2, and that'll be the length of that line.
Okay.
So how am I going to solve for x?
To solve for x.
There's a theorem at play here. And the theorem is that if you take any chord, these are called chords of the circle, and you run a radius, that the radius always makes a right angle like that. Okay? So I know this is a right angle.
Okay. Yeah.
Now, how am I going to solve for x? This now becomes a triangle problem.
Okay.
Not a circle problem anymore. It's a triangle problem. And that frequently happens. That's why I think it's really worth getting into circles. Because there's much triangle problems as there are circle problems. What's the triangle involved? In other words, what do I have to do to make this a triangle problem? Don't I have to put a radius line right there?
Yeah.
What's the length of this radius?
Just 1.
2-inch radius.
And 2 inch, so 2, yeah.
No matter where I draw the radius of that circle, it's going to be 2 inches. If I drew it down here, it's going to be 2 inches.
Okay.
Okay? So, now why is this a triangle problem? Because here's the triangle we're looking at.
A right triangle.
It's a right triangle because we know that's a right angle. This side is 1. This side is 2. Give it to me. What's this side we're trying to solve for?
We're trying to, yeah, so that would be, okay.
When I say give it to me, I mean that because we worked all day yesterday on solving right triangles.
Yeah, so this would be,
so x is equal to what?
X is equal to the square root of 2 squared plus 1 squared.
When you're solving
Minus 1
for
squared.
a
Minus 1
short
squared.
side, it's always
Yeah.
subtraction going on inside. Always.
Yeah.
It's only if you're solving for the hypotenuse that addition is going on.
Okay.
What is that number?
4 minus 1. So it'd be x is equal to 3.
Think of your words.
So 2 times 2 is 4 minus...
Yeah, no, you said everything right, and I think
Okay.
in your head you're thinking it correctly. But I want you to stop and think about your words, because you frequently say things not the way you mean them.
So it'd be x is equal to 3 square root of 2.
No, just the square root of 3. In other words, it's
Oh,
the square root of 4 minus 1, which is the square root of 3.
Yeah.
Okay?
Yeah, my bad.
And when you first said it, you said x equal to 3.
Yeah, I forgot to put the square root in.
Square root. That's why I tell all my students, make sure the first words out of your mouth are square root. And
Yeah.
they were for you, but then you took them away when you got to the end.
My bad.
Nobody wants to take them away. One way or the other, even if they're the first words out of their mouth. So
I have hard feelings for square roots.
Well, they're a little confusing to everybody.
Yeah.
Now, it's a very interesting question. Why is that answer not on there?
That's a good question.
Why is that? We just figured out that this was the square root of 3. What's their question?
What is the length of the line?
Line from there to there.
Okay.
So what is it?
So the length of that line would be just 2 square root of 3.
Yes.
Cool.
Okay, good.
Alright.
That problem was no more difficult than the previous section. And same thing here.
Yeah. Okay.
These just look a little strange, that's all. You're not used to seeing so many circles and semicircles.
Yeah.
Each of those 3 shaded regions is a semicircle. And they're giving us the diameter of one relative to the other. So this kind of, what's the area of the entire shaded region? Okay, so they're saying that that's 4.
Yeah.
What's the radius of the little circle, the littlest circle, the radius of the smallest circle?
The radius of a small circle would be 2.
Okay. And now let's go down to some of these others. CD is twice BC, and BC is twice AB. So which one can we immediately figure out next?
BC is 4.
Yeah, let's call this AB here. The radius of the AB circle, semicircle, is 2. What's the radius of the BC circle?
Yeah, the radius of BC is also, is 4.
Okay, and then what is the radius of the CD circle?
The radius of the CD circle is 4. Well, 2 BC, so it'd just be 1.
What does this mean? Look at it, it's bigger. It's bigger by how much?
2 times BC.
Okay. What was
That'd be 4.
What was the radius of BC?
4. So it'd have to be 8.
Okay.
Alright.
Another thing I'd like you to do is that when you come up with your answers, check them to make sure they make sense.
Yeah, that didn't make sense.
It would not have made sense to write 4 there. We can clearly see that as a much bigger circle than that.
Yeah.
So when you look and you see that your answer doesn't make sense, well, that's your clue to go back and rethink it.
Yeah.
Okay. Now,
Okay.
area of the entire shaded region. Let's find the area of this semicircle.
Okay.
Add it to the area of this semicircle and add that to the area of this semicircle.
Okay.
Okay.
So it'd be 4.
Of that semicircle.
4.
No, your answers always have to have pi in them.
Yeah, so 4. My bad. 4 pi.
Look at the answers. All of them have pi in them.
Yeah, my bad.
That would
So
be
just
the area of a whole circle. Again,
Mhm.
we're dealing with semicircles.
Okay.
So in other words, if
So it'd be
I had a whole circle there and its radius was 2, its area would be 4 pi.
yeah.
So what's the area of just half of it?
So the area of just half of it would be 4. Or just 2.
What's half of 4
2
pi?
pi.
2 pi.
Yeah, 2 pi.
In other words, the pi doesn't go away.
No.
What's the area of the middle semicircle?
So that would be 4 pi. So the area would be 8 pi. And then just half of that would be 4.
Area is pi r squared, not 2 pi r.
Okay.
What's the area of this semicircle?
16.
Divided by 2.
Yeah, which would be 8.
8.
Okay. 8 pi. Yeah.
I'm going to mention it every time you drop the pi because it's really, really important not to drop it.
Yeah, definitely.
Okay, and finally, the area of the large semicircle.
32 pi.
Good.
Cool.
What's the sum?
42 pi.
Good.
Cool.
And you did that without the calculator, I know.
Yep.
You did add those two numbers first, and then you added 2 to it.
Yep. Uh-huh.
That's definitely the way to do it, too.
Cool.
Now, let's look at this one.
Mhm.
We have 7 minutes to go.
Okay.
Now, again, we have the same kind of thing we had going on in our first circle in that we don't have a chord, but we have kind of a chord.
Yeah.
Okay? And we got the circle, the radius of the circle. In other words, we don't have the full chord, but that's okay. We have this part of it. Same holds true, that has to be a right angle.
Yeah.
And that's the way they've drawn it this time. Properly. Now, if the area of the circle is 100 pi,
yeah.
and the length of CA is 6, let's write that in, 6.
Okay.
What is the length of AB? This one has all kinds of stuff we're going to have to figure out before we can figure out the length of AB, but it's not hard. Each step is easy.
Okay.
Okay? Again, let's complete this triangle. That's the radius of the circle. Well, they've told us the area of the circle is 100 pi.
Yeah.
Can you figure out the radius of the circle from that?
Yeah, it'd be 50 pi. Because it's half of the area.
Hold on, be careful.
Okay.
How do I solve this equation for R?
So when
This is an equation. You can tell already that you're going to have to solve that equation a lot. This is the second time we've encountered it already.
Yeah.
Where we have pi r squared on one side. And we're trying to solve for r. What's the first thing we're going to do?
Just Oh, it was divide
by,
by r squared.
no?
Or divide by pi. Yeah.
Now,
And then so it'd be 100 is equal to r squared.
and the final line,
R is equal to 50.
no. That's not 2r.
It's r squared. Oh, so it'd be 10. My bad. Yeah. Okay.
We've solved for r. That's
Mm-hmm.
10. Now, do we know what OB is?
Well, we know O is 100 pi, but we don't know what B is.
Of OB, do we know how far it is from there to there?
No.
Yes, we just solved for it.
Oh, it'd be 10 then?
Yeah. In other words,
Okay.
all radiuses are equal. Very important concept in circles. No matter where I draw the radius, I could draw it out there, it's 10. So
Okay.
we calculated that it was 10 from here to here. Well, that means it's 10 from there to there also.
Yeah.
So if we can solve this triangle and come up with the measurement from A to O, well, then we can come up with A to B.
Okay.
So again, we have a triangle problem. Here's our triangle. That one's 6, that one's 10. Can you figure out what that one is without using math?
16. Wait, no. No.
Your basic Pythagorean triangles, and these are the ones you're going to run into a ton, they like to put them on there because they don't require you to do any math.
Yeah.
Other than recognizing that you're looking at one.
Uh-huh.
How do I know this is a 3, 4, 5 triangle? There's the 3 side, there's the 5 side.
Yeah.
That's twice 3, that's twice 5. This, therefore, has to be
8.
much faster than doing it the hard way.
Yeah, definitely.
So learn to recognize 3, 4, 5 triangles, at least this one, because you'll run into it so much.
Yeah,
You may not run into it in geometry class so much, but I guarantee you that all your tests that you take to display your geometry skills, that's a huge thing to recognize 3, 4, 5 triangles.
Yeah, definitely.
So, AO is 8. What is AB?
AB would be 4.
What is OB?
Wait. OB is 10.
What is AB?
So it'd have to be 2. Okay. Cool.
And notice how many things we had to solve for. We had to solve for R first. We had to solve for the distance from O to B, which was also R. And then we had to solve from O to A, which was the side of that right triangle. And then we had to subtract that from OB. So there were 4 steps to coming up with that. And ultimately, geometry comes down to just steps. In other words, if I give you a super hard problem, maybe there's 12 steps in it.
Yeah.
None of them are particularly hard steps. All of these steps were really easy.
Yeah, for sure.
I mean,
yeah, they're like short multi-step.
Yeah, exactly.
Oh, yeah.
There's not, so the problem really becomes one of conceptualizing it properly. Knowing that OB is also a radius. That we wouldn't have been able to solve it had we not realized that.
Yeah.
Okay. I'm going to send you a couple of pages of homework tonight. But yeah, because our next session isn't until Thursday. They won't be hard, but I'll send you a little something.
Okay.
Just so we'll have done it. Okay?
Okay, sounds good.
I will enjoy your first day back tomorrow, and I will talk to you at 5 on Thursday.
All right, that sounds good.
Okay.
Thanks, Mr. Cowan.
All right, bye-bye.
All right, bye-bye.